of solving all of our methods of solving linear systems. Now we're going to put it all together and look at problem solving. So word problems with linear systems. So just to review, the three types of solving systems that we discussed was graphing. So just through graphing your two lines on a Cartesian plane and finding the point of intersection. We've done it through substitution, where you rearrange an equation in terms of one variable and substitute it into the second equation. Or elimination, where you use addition or subtraction, sometimes multiplication, in order to remove one of the variables to solve for the other one, and then replace it back into one of the equations to solve for the one you didn't initially solve for. So when we're looking at word problems, you can choose to solve by elimination or substitution. You can pick either way. So totally up to you, whatever one you like better, pick the one that you feel more comfortable with, if it doesn't tell you which one to use. So steps, write down the two equations. Either equation will be in the form of y equals mx plus b, or in standard form. So this form here is our slope y-intercept form, and this equation, the second one, is standard form. So working with either form is acceptable. Decide which method that you are going to solve with, so either substitution or elimination. Solve for your x and your y points, and remember that those are x and y coordinates, and that is your point of intersection. And then write your solution with a concluding statement. So we want to see a therefore statement at the end of your problem solving. So let's take a look at the first example. It says the Ajax Minor Hockey Association would like to rent a banquet hall for their annual awards dinner. They received two quotes. La Gala Banquet Hall charges $500 to rent the room, plus a $15 fee for each meal. Tosca Banquet Hall charges $350 plus $18 for each meal. The association wants to know when both places will cost the same amount. So the association basically wants to know, where is the point of intersection? So we're going to start by writing our two equations. So we've got La Gala Banquet Hall. So we know that their total cost is equal to the $15 per meal plus $500 to rent the hall, whereas Tosca Banquet Hall total cost is equal to, let's see, a rate of $18 per meal plus a $350 charge to rent the hall. So for this, when we look at these two examples, we've got y equals 15x plus 500 for the first banquet hall. And then for the second banquet hall, we've got y equals 18x plus 350. So right away, I can see here that these variables are the same. So they're the same variable with the same sign. So that would indicate we can eliminate these. So we are going to eliminate these by subtraction. So I'm going to rewrite them out just so they're 15x plus 500. And then we've got the same sign and the same coefficient. We assume here would be 1. So if we think back to our rules with elimination, we are going to subtract. Oops, that's 350. $350. So because they're the same, we are going to subtract these equations. So 1 minus 1 is 0. And then we've got 15x minus 18x would be negative 3x. 500 minus 350 would give me positive 150. So this looks a little different from how we did it before, but realize we can take this negative 3, make it positive, send it to the other side of the equal sign, and now it looks like something that we can solve. So to isolate this x, we divide by 3 from both sides. X is equal to 50. So this is the first part. So we know the first part, when we sell 50 meals, that the price is going to be the same. So let's figure out what that total cost is going to be. So this is part A of our solution. Remember, that's when we solve for our first variable. Part B is when we take this 50 and sub it back into an equation. So I'm going to sub it into the first one. So 15x becomes our 50 plus 500. Oops, that's 500. I'm going to use this because it's a little quicker and a little neater. So 15 times 50 is 750. We're going to add 500 to that, and we're going to get y equals 1,250. So that's our part B. Our part C of this is when we say our point of intersection with coordinates x, y is equal to 50 and 1250. So therefore, when we answer the question, the association wants to know when both places cost the same amount. Both places cost the same amount of $1,250 when 50 people attend. And that is the solution to this system of equation. So the trickiest part might be coming up, with the two equations. But once you have them, just use those, use the strategies that we talked about during each lesson to figure out the system. So we're just going to do one more example. So it says the difference between two numbers is 45. 3 times the larger number less 5 times the smaller number equals 75. What are the two numbers? So in order to organize this, let's define our variables. So let x represent one number and let y represent the other number. So we've defined our variables. Now we have to come up with our equations. So the difference between two numbers is 45. So if the difference between two numbers, that's a subtraction. So x minus y is 45. So the difference between two numbers is 45. So x is one number, y is the other number. So we've got our first equation. Our second equation says 3 times the larger number less 5 times the smaller number equals 75. So 3 times the smaller number less 5 times 3 times the larger number less 5 times the smaller number equals 75. So these are our two equations for this system. When we solve this, let's solve this one by substitution. So I'm just going to rearrange this first equation and make it in terms of x. So I'm going to take this y and I'm going to send it over. And then I'm going to get x is equal to 45 plus y. So when we take it over, we change the integer sign. And then I'm going to sub this value right here, so this value, in for this x when I solve. So my next line here is 3x, 3, and then I'm going to substitute in what I said x was up here. So 45 plus y minus 5y equals 75. So then I'm just going to solve. So distributing this 3 into the set of brackets there, 3 times 45 is 135 plus 3y minus 5y equals 75. Collecting like terms here and sending this 135 to the other side. So positive 3y minus 5 is negative 2y, which is equal to 75. 75 minus 135. Negative 2y equals negative 60. And then you guys know here we're going to isolate, divide it by negative 2, and we have y being equal to 30. So we have solved for one variable using substitution. So then we're going to solve for the second variable by subbing 60 in, or 30 rather, into an equation. So I'm going to use the top equation because it's a little bit simpler to work with. Minus y equals 45. X minus 30 equals 45. X equals 45 plus 30 when I rearrange, and a final answer of x equals 75. So we've got our point of intersection with our x and y coordinates, where x is 75 and y is 30. So then you need your therefore statement. Therefore, one number is 75 and the other number is 30. And that is it. I know this wasn't super exhilarating for a lesson, but it's just reinforcing the methods of substitution. So make sure you practice these guys and check the weekly schedule for your work for the day. Thanks.